There are different methods of preparation of nanoparticles. Today we will learn sol-gel synthesis. The sol-gel process is a wet chemical technique. Now this is called the wet chemical technique because here water is used as the solvent. This is also known as chemical solution deposition. This is a cheap and low temperature technique that allows for the fine control of the chemical composition of the products. This is called sol-gel method because in this chemical procedure, a sol or a colloidal solution gradually evolves to form a gel. This is used to synthesize nanoparticles of metal oxides. The synthesis involves 3 steps. The first step is hydrolysis. During hydrolysis, the sol is formed. The sol is formed from another material which is hydrolyzed with water, and that substance is usually the metal alkoxide or the metal salt whose metal oxide nanoparticles are to be synthesized. So we can represent the metal alkoxide as MOR, where R is any alkyl group. Now this is taken in a solution form and this reacts with water. Reaction with water is called hydrolysis. And when it reacts with water, it forms metal hydroxide MOH plus ROH. Now this metal alkoxide is a solution. It is a homogeneous solution. While this metal hydroxide, since it is insoluble, it is in the form of colloidal particles. So this is a sol. It is a colloidal solution. So this is the sol which is getting converted into the gel. And this is happening by the second process, which is the condensation. During condensation, the MOH reacts with another molecule of MOR and results in the formation of MOM bonds. And this process continues and results in the formation of a cross-linked structure. Now this is the sol, metal hydroxide, this is the sol, and when it forms a cross-linked inorganic polymer, this gets converted into a gel. Now third step is the removal of the solvent. The solvent has to be removed from the gel so that we get the nanoparticle separated. This can be shown schematically. In this beaker, some metal alkoxide is taken, MOR is taken. And since metal alkoxides are not soluble in water, it is first dissolved in small amount of ethanol and water is added. Now this is a homogeneous solution. Then it is placed over a magnetic stirrer and stirred for a long time. During that process, the metal alkoxide gets hydrolyzed to form the metal hydroxide. And when the metal hydroxide is formed, since it is colloidal in nature, this forms a colloidal solution. A colloidal solution is one in which the particle size is between 1 to 1000 nanometers. In normal solution, in a homogeneous solution, the particle size is less than 1 nanometers. So this contains MOH and this is the sol. And this salt is kept undisturbed for a long time, maybe hours or days, when this gets converted into the gel by the process of condensation, which leads to cross-linking between the particles, resulting in formation of MOM bond. So this is the gel which is formed by the condensation. It consists of MOM cross-link bonds. Now the gel is semi-solid in nature and it contains the solvent molecules inside it which has to be removed. So next step is the removal of solvent from it, and this can be done in a number of ways. The simplest method is sedimentation and then pour off the remaining liquid. Or if centrifugation is done, it will accelerate the process of separation of the solvent. After removal of the solvent, it is dried. Drying leads to shrinkage and densification. Densification is the process of increasing the density. So drying leads to shrinkage and densification. It can be subjected to further thermal treatment, which can lead to further polycondensation and enhancement of mechanical properties and structural stability. The second one is colloidal precipitation. This is a chemical process involving formation of colloidal precipitates, and this can be used for fabrication of nanoparticles. We'll see an example of fabrication of gold nanoparticles. Here, a gold-based compound tetrachloroauric acid HAuCl4. This is reduced to gold nanoparticles. Here, the oxidation state of gold is Au3+. And this Au3+ is converted to Au0 by using a reducing agent trisodium citrate. This process is known as French-Terkevich method. So in the synthetic procedure, first step is tetrachloroauric acid is transferred into a conical flask and it is kept on a hot plate for heating until it boils. The magnetic stirrer is used to stir the contents of the flask and the required amount of sodium citrate solution is added to the flask while continuing the heating. Now during this process, the Au3+ is reduced to neutral Au particles, and within 20 seconds the solution begins to turn to a dark purple color. While it is continued heating, the color changes the shade from purple then to orange, and depending upon the ratio of sodium citrate to tetrachloroauric acid. After 15 minutes, the flask is removed and immediately quenched into ice bath. When this is done, the reaction stops and the nanoparticles are not produced anymore. The nanoparticles are then separated and analyzed for its characteristics. Next is co-precipitation. Magnetite nanoparticles are synthesized by co-precipitation reaction. Magnetite Fe3O4 contains both ion in the Fe2+ and Fe3+ form. In the experimental procedure, the iron salt taken is FeCl3, and to this NaOH and 1,2,4,5 benzene tetracarboxylic acid are added, dissolved in water. It is stirred for 10 minutes. Precipitate is filtered and dried, and the powder is calcined at 450 degrees centigrade for 2 hours when Fe3O4 nanoparticles are formed.
Now next is the combustion technique. So combustion technique, it is a simple and easy, convenient method for synthesis of nanomaterials. We are using the principle of combustion and we are applying it for synthesis of nanomaterials. It is based on principle of fuel chemistry. Now here, redox reaction is taking place, which is thermally induced. And redox reaction is between an oxidant and a fuel. Just like any combustion reactions, you have an oxidant and a fuel which act as the reductant. So between an oxidizing agent and a reducing agent, the reaction takes place and a lot of heat is released. That is the process of combustion, and along with that, there is evolution of a lot of gases also. So that principle is used for synthesis of nanomaterials. And it is self-propagating high temperature synthesis. Self-propagating means once it is initiated, it will go on by itself. And this combustion, since it produces high temperature, it is called self-propagating high temperature synthesis. And nanomaterials are synthesized by the exothermic reaction that is taking place between the oxidant and the reductant. And the heat is generated due to the exothermic reaction, due to the combustion reaction, which is exothermic. During combustion reaction, a lot of heat is released, and that heat is used for synthesis of the nanomaterials instead of heating for a long time in a furnace. So the difference is that instead of heating the starting materials in a furnace for a long time, here the heat released during the exothermic process is used. So once the reactants are ignited, large amount of heat is produced, and that supports the reaction to continue. Now, the propagation of the combustion wave, the heat released during the process is transmitted as the wave through the sample. It causes the conversion of the reactants into the products. An example is given, synthesis of nanoparticle sized LiBiO2 powder. Now, it need not be LiBiO2, it can be any other oxides. And for that, we are starting with the nitrate of the element whose nanoparticle oxide you want to synthesize. So here it is a mixed oxide of both lithium and bismuth, LiBiO2. So here the starting materials are lithium nitrate and bismuth nitrate. So if you are taking some other element, if it is iron, you have to have iron nitrate. So it is a mixed oxide of lithium and bismuth. So lithium nitrate and bismuth nitrate are taken. So the reaction is taking place between the oxidant, which is the nitrate, and urea. And here glycerol, in this particular process, glycerol is added as the binding material. And these three are taken, and this is kept in a preheated furnace. During that process, what happens? The solvents are evaporating and it becomes a jelly mass. Again, the temperature is increased, and during that process, the combustion reaction is starting by itself. And then when the combustion reaction starts, the reaction takes place, it is exothermic, and the whole reaction will take place within few minutes. It will result in the release of lot of gases also along with that. So you are getting the product in the form of nanoparticles.